Okay, so if you're someone who works with electricity, you know that personal protective equipment isn't just a nice to have, it's literally your last line of defense. But here's the real question. Are you actually defending against the right threat? See, in the world of electrical work, there isn't just one danger, there are two. And mistaking one for the other? Well, that could be the last mistake you ever make. Let's get into it.
On one side of the coin, you've got electric shock. We call it the silent killer. It's that classic hazard we all learn about from day one. But on the other side, you've got arc flash, the explosive threat. This is a whole different beast, a violent, high-energy event that's so often misunderstood. And thinking the gear that protects you from the silent killer will save you from the explosion, that's probably one of the most dangerous assumptions you can make out in the field.
So if we're going to get the protection right, we've got to understand the problem first. Let's really break down what we're up against with these two totally different electrical threats.
So first up, electric shock. The easiest way to think about this is to imagine your body as a copper wire. Shock happens the second you accidentally become part of an electrical circuit. It's a conductive hazard, meaning current is flowing through you, and it's powerful enough to short-circuit everything from your muscles to your heart. And don't ever get fooled by low numbers. Even something that seems small, like 48 volts, can absolutely be fatal under the right or wrong conditions.
Now, let's flip over to the arc flash. Look, if shock is a silent assassin, an arc flash is a bomb going off right in your face. The danger here isn't current flowing through you. It's a massive, explosive release of pure energy happening right in front of you. We're talking a violent blast of thermal energy, blinding light, and incredible pressure.
To really get your head around the sheer violence of it, you've got to think of it in two parts. First, there's the flash. That's the blinding, searing thermal energy. But then, there's the blast, the explosive force. And as this quote really highlights, you're dealing with an explosion of gas and molten metal flying at you at over 700 miles an hour. Just let that sink in.
And the dangers come at you from all sides. You've got shrapnel, actual molten metal coming at you fast enough to tear right through normal clothing. You're hit with a pressure wave so strong it can literally throw you across a room. The sound alone, at 140 decibels, can rupture your eardrums. The light can cause permanent blindness. And the heat, my goodness, the heat can cause fatal burns from 10 feet away. This is no silent killer. It's a brutal, all-out assault on your body.
So how in the world do we protect ourselves from these things? Let's start with the first threat, electric shock. The solution here is all about one word, insulation. And the absolute cornerstone of that solution is the insulating glove system.
Now, protection starts with picking the right tool for the job. You can see right here from this chart of ASTM D120 classifications, every single glove class has a maximum use voltage. Your first step, always, is to know your system's voltage and then pick a glove that's rated to handle it. Grabbing a Class 1 glove for a 17,000 volt system isn't just a mistake, it's a potentially fatal one. You have to match the gear to the hazard every single time.
But listen, it's not just about the rubber gloves. You need to think of shock protection as a three-part system. Yeah, the rubber gloves are the star player. They provide the actual insulation. But the leather protectors you wear over them are just as crucial. They're the bodyguard protecting the rubber from cuts and punctures. And if your arms might get near energized parts, those insulating sleeves are what complete the protective barrier.
But remember this, your gear is only as good as the condition it's in. That's why OSHA requires a daily inspection before your first use. This 5-step process you see here, from a visual check to that critical air test for pinholes, all the way to checking the test date, this isn't just some friendly suggestion. This is your most important daily ritual to make sure your last line of defense is actually ready to defend you.
Okay, so we've insulated ourselves from shock. We've built our barrier. But what about that bomb going off? Now we have to solve for the explosive thermal threat of an arc flash. And this, folks, requires a completely different philosophy and a totally different set of gear. And this right here, this is probably the single most important distinction you need to burn into your memory. As this quote makes crystal clear, an arc flash suit does not protect you from electric shock. Its one and only job is to shield you from the insane thermal energy, the burning injuries of an arc flash. Let me say it again, they are not interchangeable. And this is what that protection looks like. It's a full suit, from head to toe, complete with a hood and a face shield, and it's all designed to do one thing, withstand a massive fireball. This isn't about stopping current anymore, it's about stopping fire. So, the key number you need to know for arc flash protection is calories per square centimeter. Now, I know that sounds a bit technical, so think of it this way.
1 calorie per square centimeter is like holding your finger over a candle flame for 1 second. The serious arc flash suits are rated to withstand 40, 75, even over 100 calories of that energy. That's a lot of heat.
So how do you know what level of protection you actually need? Well, the good news is you don't have to guess. Standards like the NFPA 70E give us a really clear, systematic way to figure it out. And one of the most common ways to do that is called the PPE category method.
And you know, the beauty of this method is really its simplicity. By helping you identify the specific task you're doing and the kind of equipment you're on, NFPA 70E lets you quickly figure out your required PPE category. It just takes all the dangerous guesswork out of the equation.
This table just lays it all out perfectly. You can see exactly how the required gear escalates as the category and the danger goes up. At Cat 1, you might just need an arc-rated shirt and a face shield. But once you get to a Cat 4 hazard, the stakes are way higher. Now you're required to be in a full flash suit and hood, one that can take at least 40 calories of energy. That's like holding your finger in that flame for 40 seconds.
So, we've covered the gear, and that's absolutely essential. But the gear itself, that's only half the battle. Your truest, your final line of defense is your own knowledge. Understanding the standards and applying them with discipline every single time. These right here are the rule books that define modern electrical safety. OSHA sets the law. NFPA 70E is your practical guide for how to work safely. And standards like ASTM D120 give you the nitty-gritty details on your equipment. Knowing these isn't just about being compliant. It's about survival. You know, this all really boils down to one final critical question that you have to ask yourself before every single job. Just stop, look at the task in front of you, and ask, have I properly sized up both the shock hazard and the arc flash hazard? Do I have the right specific PPE for both of them? Because recognizing they are two separate threats is the key to going home safe at the end of the day. In the end, it all comes back to this, doesn't it? The standards, the gear, the procedures, all of it exists for just one reason. Your skills, your knowledge, your hands. That's your livelihood. Make sure you're protecting the person who makes it all happen.